Alright guys, at the end of the last video from yesterday, I did dismiss you just a little bit early, so I did want to include this in our next set of notes in case you missed this. If you caught this part, you are welcome to go ahead and skip ahead a little bit. So one of the last questions in your notes from the previous day's lesson includes this question about popcorn. And there is a kind of a hint here for an upcoming test, so please do make sure that you hear this part of this question. Because we know that a cone is a third the size of a cylinder with the same base, we should be able to safely assume that whatever this cost is should get multiplied by 3 to give us the price of the popcorn. But if it's not, that means we're getting a much better deal to buy the bigger component of popcorn than we are to buy 3 small ones. And a lot of times at different restaurants or even in stores, that is the case. If you buy in bulk, it's typically a little bit cheaper. So because that cost is only double, we're actually getting a third of that container for free, if you will, based on the price of the smaller one. So keep that in mind. That might be a helpful hint for an upcoming quiz or test question. So now let's talk about spheres. So a sphere is a set of all points that is equidistant from a given center. And that should say equidistant. That typo is going to bug me there, but that's what that definition actually is. We've already talked about chords, we've already talked about diameters, we've already talked about a radius, but those definitions are here if you need them. So for surface area of a sphere, we have 4 pi r squared. And I'm going to show a visual once we get to looking at where that comes from here in just a moment. But for now, we're just going to trust it. For the volume of a sphere, we've got 4/3 pi r cubed. Now for the volume of a sphere, there are a lot of great YouTube videos out there about why this works and what they're actually doing. For sake of time, we're just going to trust that one, but you are absolutely encouraged and welcome to look those up. However, for surface area, it's a little bit easier to explain. If you have ever cut open a softball or anything like that, or a tennis ball, you may have noticed kind of what that general shape looks like. And I'm going to pull up here a picture of that that's a little bit nicer for us to be able to see that. So with that, if you can kind of picture taking a sphere or a baseball, softball, whatever, and cutting it open, what you end up with is you end up with 4 circles that appear. Oops, sorry guys. So with that, what you're really doing when you're finding the surface area is you're finding 4 circles that would cover up this particular sphere. Now you'll notice also that we're not going to talk about lateral area here because there is no base of a sphere. It's all a curved surface, so there is only surface area for a sphere. There is no lateral area. So we're going to practice this a little bit here too. Keep in mind, since pi is in some of these questions, we definitely could end up with leave it in terms of pi in our directions. However, in this case, they don't ask for that, so all we have to do is plug in to the formula 4 pi r squared. So 4 times pi times 8 squared. We're going to round here since they did not indicate that we had to leave it in terms of pi. So that's about 804.2 square inches. As far as volume goes, we've got 4/3 pi r cubed. Unfortunately, this is going to be one of those formulas that you're just going to have to memorize. Like I said, though, you're welcome to look up some videos as to where this is coming from if you're interested. So 4/3 pi r cubed. Again, it doesn't say to leave it in terms of pi, so I'm not going to do that. And we end up with approximately 2,144.7 cubic inches. Quick things here, guys. Again, make sure that you are using the actual pi button, and when you are raising something to the 3rd power, instead of squaring it, you should have a little up arrow on your calculator that will allow you to write that exponent. The surface area of a sphere is 20.25 pi square centimeters. What is the diameter? So I'm going to make a note to myself that I want to know what the diameter is, and then I'm going to look at what I know. So I know the surface area is 20.25 pi. I know the surface area formula is 4 pi r squared. So if I divide by pi on both sides, they're going to cancel out. but I can divide by 4 on both sides, and I end up with r squared equals 5.0625. Since this is a terminating decimal, meaning it doesn't go on forever, I'm going to write every digit until I have to round, or if I have to round at the end. So now I'm going to take the square root of that answer, and my radius comes out to be 2.25 centimeters. Now, since that's the radius, we have to double that to get the diameter. So the diameter would be 4.5 centimeters. Now, this next question here talks about sphering. I've also heard this called zorbing. And normally, if you're in class, we kind of talk about if anyone has done that before. To me, this sounds like my ultimate doom. I would not want to do this particular adventure just because I'm a little claustrophobic. But if you've done it and you enjoyed it, that's awesome. But let's take a look at this question. So it says, a person rolls down a hill inside an inflatable ball surrounded by another ball. The circumference of the outer ball is 12 pi feet. So my circumference is 12 pi feet. Find the surface area of the outer ball. So remember that your circumference formula is either 2 pi r, or we can think of it as pi times diameter. Either way will work. Since I'm going to need my radius in the surface area formula, I'm going to use 2 pi r. If I divide by pi on both sides, that's going to cancel out. If I divide by 2 on both sides, my radius comes out to be 6. So then my surface area formula is 4 pi r squared. So 4 times pi times 6 squared. It doesn't tell me if I need to round this or not. So just for sake of practicing, I'm going to leave this one in terms of pi. So 4 times 6 squared is 144 pi, and this is square feet. Now realistically here, we would probably round this in the real world situation, and it doesn't say which one we need to do, so I would take either one of these two answers as your final answer. So looking at this here, this visual is a little bit hard to see, I think, but basically this is kind of like a dog bowl, where you've got a cylinder with a half sphere or a semi-sphere cut out of this figure. And typically we don't call it a semi-sphere. I've used that because we've talked about semicircles, but we typically call that a hemisphere. So kind of what we're going to do here, if we want to find the volume, we're going to find the volume of the entire cylinder as if it was complete, and then subtract from it half the volume of the sphere, or the volume of a hemisphere, if you will, because we've got this cut out of this bowl type shape. So for a cylinder, our generic formula for volume, if it doesn't come to a peak at the top, is base times height. And I know my volume formula of a sphere. Now for the cylinder, since my base is a circle, that's going to be pi r squared times height minus half of 4/3 pi r cubed. At this point, I've got my equation written. I just need to plug in. My radius and height are both 2, so that makes my life pretty easy. 2 squared times 2 minus half of 4/3 pi times 2 cubed. Again, they do not ask me to leave this in terms of pi, so I don't have to. But if we would like to leave it in that format just for practice, 2 squared times 2 is going to give me 8 pi. Half of 4/3 times 2 cubed gives me 5 1/3 pi. So if I take 8 minus 5 1/3, that's going to leave me with 2 2/3 pi. However, in all honesty, since they don't tell us we have to leave this in terms of pi, I probably wouldn't. I probably would type pi times 2 squared times 2 minus half of 4/3 times pi times 2 cubed. And that's going to give me approximately 8.4 cubic inches. As far as spheres go, we've pretty much covered all of the major bases here. Here you're looking for surface area and volume, so kind of thinking through this a little bit, I'm just going to write a generic setup for this, and then I'm going to let you guys try these on your own. Remember that you can definitely email me if you have any questions or concerns as you move forward. So let's look at what we've got. So with volume, we would find the volume of the cylinder minus half the volume of the sphere, kind of like we did before. However, for surface area, we would need to be a little bit more careful. We would need to have the lateral area of the cylinder plus one base of the cylinder, right? Because the other base has now been cut off, plus half the surface area of the sphere. Same thing for number 22. Even though it's inverted the opposite way, this would also be our way to find our surface area here. And then for the last one, we need the lateral area of the cone plus half the surface area of the sphere. Volume-wise, for both of these next two, we would be adding the volume of the cylinder plus the volume of a half sphere, and the volume of a cone plus the volume or half the volume of the sphere. So just kind of some guidance here on how to look at those. We are going to take a peek at one final question before we close out. So it says a sphere is inscribed in a cube with a volume of 64 inches. What is the surface area of the sphere? So what this means is we've got a sphere that fits perfectly inside of this cube. And I know that my cube has a volume of 64 cubic centimeters. So think about this. For volume, we're doing the area of the base times the height. But since the base, the height, and your width, if you will, or your length, if you will, all of those dimensions are all the same. So really, whatever the side is gets cubed, because length, width, and height are all the same. So this is where we need to be able to take a cube root in our calculator. And we haven't done that yet in this class. So depending on what type of calculator you have, you may be able to, if you have a TI-84, click the math button and find the cube root. But for any other root higher than 3, you're going to have to do it the same way that we're going to do this. So we're going to type 3 into our calculator, and we're going to hit second, and there is a square root button that looks like this. It looks like X root. So we're going to hit second and that button, and what that does is it takes whatever number you put out front as the power of the root. So we're going to take a cube root of both sides. So the cube root of 64 tells us that each side of this cube is 4 centimeters long. So since this sphere fits perfectly in here, if we can kind of get a visual of what's happening, and forgive me for my art here, we've got this sphere that's fitting perfectly in there, and if this entire side is 4, then that means my diameter is also 4, so that means my radius is 2. So my surface area formula of a sphere is 4 pi r squared, so 4 pi times 2 squared. It doesn't say if it wants it in terms of pi or not, so I'm just going to go ahead and type it all in my calculator, and we end up with about 50.3 square centimeters. Guys, as always, if you have any questions or concerns, feel free to email me. Have a wonderful day.